Hey guys, so today we're going to start with reporting category 2, and these are some more hints and tricks to pass the geometry SOL. So this reporting category is triangles. Yes, we have completely spent most of our year on triangles, so this is a pretty big one. With that in mind, this is what we've learned about triangles. We first can determine if there is a triangle. We have to order the lengths and the sides by length given the angle measure, order the angles by degree measure given the side lengths, and determine the range for the third side. Then we prove triangles congruent, prove triangles similar, and then we talked about just right triangles. So we're going to go through a few little things to get us going. The first thing we're going to talk about is how to order these things. And I like to make a chart. So when I make a chart, I go back and I think about what would I have done if they want me to order these from smallest all the way to largest. And you can make this chart on your SOL with the drawing tool. So the only thing that I can actually see in here right now is actually numbers. And I know how to put numbers in order, so I'm going to do that. The smallest number is 15. The next smallest number is 21. And finally, the largest number is 23. And I'm going to take that. Next, I've done that. What's next? I have these letters. I have triangle, QRP. So I'm going to ask myself, where is the 15? Well, the 15 is between the Q and the R. The 21 is between the R and the P. And finally, the 23 is between the Q and the P. Next, I'm going to say each column, and in case you're wondering what a column is each section of the chart. So in that first column, I have a Q and an R. This is triangle QRP. Which letter is missing? Oh, letter P. In the next column, I have R and P. Which letter is missing? Q. Finally, in the last column, I have Q and P. Which letter is missing? R. So if I look at this, and I say, what are my angles in order from smallest to largest? There they are. Of course, on the SOL, I'd have to be extra special and put angle measures. And if I'm talking about measures, I might even need an M there. But for the purpose of trying to figure it out quickly, I can just go through the chart method. Now, this looks really complicated. This stuff over here on the left is just what I'm going to be doing. Follow it along if you want. So, step 1, I have to figure out if there's any implied information. All the triangles I've given you, they don't even connect. So we're not even going to worry about step 1. In step 2, it's do the triangle markings match. Remember, from before, I can rotate, I can translate, I can reflect. The only thing I can't really do here is dilate. But I can move these things around and they can still be marked the same. So these two are marked the same. Then I'm going to pick one triangle. For my sake, I like to cross the other triangle out. And then where there are markings, I'm going to either mark an angle or a side. Now don't forget, we took care of implied information up at the top. So those like little arrow marks that could be on parallel lines, those don't get marked. So right here, I see that I have an angle that's marked. This one is a side, and this one is an angle. Over here in this abyss, I have a bunch of X's. Now because triangles have 3 angles and 3 sides, I expect to have 6 total letters there. I cannot, going around the perimeter of the triangle, I'm just going to walk around. I cannot go over 3 X's. So that leaves this to be angle, side, angle. In example 2, the triangles also match. I'll cross this one out this time. I'm going to mark my X's and everything else that I know. Now, I have 2 X's here, so I can't go this way. Can't do it. I'm a math person. We like order. I'm going to start alphabetically, and I go around this way. And I get A, S, S. Uh-oh. I cannot get ass in geometry unless one condition, it's the right ass. Since this has a 90-degree angle, this becomes HL. So the only possible way it works in geometry is if you have the right ass. And the last one, these things match. I'm going to put some X's in, and I end up getting side, side, side. So if I'm trying to prove 2 triangles congruent, I can do this, and there's only 5 methods that work. And you have to know what they are. They're right here. It's side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. Now hypotenuse, leg, of course, is the right ass. So now that I know how to prove triangles are congruent, of course in geometry we're never done. We're going to have to do a proof. It's going to be some 2-column thing. They're going to give us some given and some proofs. I like to take a second and go over things to know about givens. Givens, the reason are given, that's pretty nice. I just know it to be true. But some of the things that they might tell me. They might give me some words. For example, over here they told me the word midpoint. They might also say bisects. It could bisect an angle or a side. That means cut into 2 equal pieces. It could also give me a symbol like this, which means perpendicular. Which, by the way, is my favorite symbol because it kind of tells you that it hits at 90 degrees. In case you didn't realize it. That may be the only other words. If you're given words, any word, you have to define them. Now, remember, our goal almost all the time is to prove these things congruent by one of the big 5, which we just talked about. Side, angle, side, 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 angle, side, angle, 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 side, or HL. I'm talking about sides and angles here. So the word midpoint is probably going to tell me something about some kind of side. Bisects could be bisects an angle or bisects a side, which also gives me a side or an angle. Perpendicular is going to give me an angle. Some of the other things they might give me. They might talk about parallel lines. If they talk about parallel lines, I need to know that my alternate interior angles are congruent. Those are my Z angles, and remember you can write that Z backwards or upside down, rotate it, flip it, do all that thing, just don't dilate. The other one is corresponding angles. That means they're sitting at the exact same spot in different angles. Sometimes we refer to these as our F angles because they're sitting in the exact same spot. The only other thing that is not in a given, but that we might have to know, is my reflexive property, and that's just when something's equal to itself. But they don't ever tell us that because we know that things are equal to themselves. So we just go ahead and just write it in. So let's go ahead and take a second and look at this proof now. The first 2 things I notice is I need to be able to label my givens. So number 1 is a given, and number 2 is a given. I cannot start with anything but something that's given to me. The one that's missing as I cross these things out is C is the midpoint of BE. Best thing about the SOL is that it is drag and drop, so I won't have to worry about my spelling. I just have to know what to look for. Now, and this also helps me because it's drag and drop on both sides, I'm going to define that word midpoint. So if C is the midpoint, that's really telling me that BC and CE are equal. or congruent. And that's the definition of the midpoint. Now I have to figure out how these two triangles are congruent. So I'll go ahead back and mark my picture. I already marked my midpoint, but I know that angle B is congruent to angle E, and AB is congruent to DE. I go back through that whole process of, are these two triangles marked the same? Well, yes, they are. So I get rid of one. I know nothing, nothing, nothing. I have two sides and an angle. I go around and I get side, angle, side. Now, my big cheat for the SOL. If I can fill out this whole chart, I know a little bit more than I'm letting on. Number one, for example, is that an angle or a side? It's an angle. Number two, is that an angle or a side? That's a side. Number three is a word. That really, it's nothing to me. Number four, is that an angle or a side? So I have two S's and one A. So if I go back to my big five, I know the only one with two S's and two A's is either side angle side or HL. Well, there's no 90-degree angle, so by process of elimination, I know that this has to be side angle side. Other fun facts: do not ever write the word prove. If you think you might write it, go ahead and cross it out. If we're talking about triangle, congruent to triangle, it has to be one of those big fives. We know it's going to work. It can never be none. If it ends with anything else, it's going to be CPC/TC, or corresponding parts of congruent triangles are congruent. Now, let's move on to similar triangles. Similar triangles are a little bit different, and these are dealing with dilations. I'm looking at one triangle and I'm changing its size. So this problem actually gives me a big hint. One of the things I love about the SOL is that it gives me hints along the way. These things, that's telling me that my sides are proportional. Now remember, in geometry, when things change size, like dilate, they get a scale factor. You have to multiply them by something, and that's where this side proportionality comes into play. I'm really just looking for the scale factor, and I'm basing it off of my triangle similarity statement. The other thing I can see here are that my angles are congruent. They stay the same, which is really nice. So when I do this, instead of having all 5 of those lovely theorems, I'm only got 3 of them. I'm either dealing with all my sides being similar, which means that they're all proportional. I'm either dealing with all my angles being the same, or lastly, a mixture of sides and angles. And when I get that mixture, then I know it's side angle side. Those are the only 3 possibilities: all sides, all angles, or a mixture. Now this problem says, select 2 relationships. You guys got to read the problems here. Select 2 and only 2 relationships that would prove that these 2 triangles are similar using the side angle side. I need a mixture. My guess is if I have to pick 2, I'm going to have to pick 1 from here and 1 from here. Those are my 2. So let's look at this again. Let me get rid of this because I don't want extra writing on here. Now, what I notice is the first one. I'm going to look in the very first box. On the numerator, notice how I have an R and a Y. So what that is telling me is I'm really looking for angle R congruent to angle Y. It's a big matching game. I don't have that over here. Because I don't have it over here, I know that that one doesn't work. So the next one below it, I see that I have E and E. I don't even have an E over there. So once again, what that tells me is that's a bad choice. Let's keep going. I'm going to look at the next one, the one that matches, because remember, this is a big matching game. I have a Y and an F. I have a Y and an F. Ooh, that looks like something I probably am going to want to choose. So my answers are going to be those two. Now, for grins and giggles, if I check the last one, I have an E and an E again. So I know that that wouldn't work. But that's how I do this problem. If it asked me for all three sides, I would probably be looking for something like that with all three sides in it. So let's keep going. Now, right triangles. So here's the deal. These 5 right triangles deal with everything I need to know about right triangles. In the very first column, over here, I'm looking at this triangle, and what I notice is all I have is angles. Since day 1 in geometry, pretty much, we've told you that inside of a triangle adds up to 180 degrees. Now I'm going to add this up like I would add up any polygon, and I'm going to say 6x plus 4 plus 50 plus 90 all together are going to equal 180. I add up all my numbers and I get 144, and I just bring down the 6x because there was no other x's. This becomes a regular old Algebra 1 problem, so I'm going to subtract 144 on both sides. I get 36 equals 6x, divide by 6, and x equals 6. This brings me up to, a lot of times in geometry, it comes down to looking at a picture, pulling out some algebra, and solving. But I have to know some facts to do that. So, next one. I have all sides. Over here, when I have all sides, no angles except the 90-degree angle, of course, I'm probably going to be dealing with my Pythagorean theorem, which is c squared equals a squared plus b squared. Now, for a moment, I'm going to tell you, don't forget, your Pythagorean theorem is on your formula sheet. So, don't forget you can find it and you'll know where it is. We have to know, where is my hypotenuse? Some people struggle with this. If you have a triangle like this and you have no clue what to do, I go ahead and I label the vertices of my triangle A, B, C. And I just do my little chart thing. Where is my 90-degree angle? It's at angle B. Which 2 letters are missing? A and C. And what that does for me is that tells me that this is my hypotenuse, or my C. So I get 14 squared equals 9 squared plus x squared. And if I wanted to solve that, I would take 14 squared, subtract 9 squared, and that equals x squared. I can continue to do the math with my calculator, but we're not going to waste time. Let's move on to the next one. Now, I have 2 sides, but it doesn't want the third one, so I'm not dealing with only sides. I'm dealing with a mixture. When that happens, I know that I'm probably going to be dealing with SOHCAHTOA. So let's go ahead and look at this. I need to pick an angle. I'm going to pick this angle right here. I have to label my opposite, adjacent, and hypotenuse. My opposite, if I just drew that circle, that purple circle does not touch this side that is opposite. My hypotenuse, I can look at my 90-degree angle with that little red square there. It does not touch the 51, which makes that my hypotenuse. And lastly, my adjacent. If you struggle with that, once again, I would go ahead and label those vertices and talk about what's across from things to be able to get your opposite and your hypotenuse. Whatever's left over is your adjacent. So, now that I've done that, if I look at this problem, the opposite has nothing by it, no numbers. The hypotenuse has 51 and the adjacent has 48. So I know I'm not dealing with the opposite. I look at SOHCAHTOA and I say which one has an A and an H. And luckily for me, I can see that that is CA. So I have cosine of whatever angle I picked, which in this case is a question mark, equals 48 over 51. Now I have to ask myself, I look at the fraction that I have on the right side of the equal sign, and I ask, where is the x? Is x in the top or the bottom? And it's a trick question. There is no x. So that tells me in my calculator, I'm going to have to hit the second key. When I do that, you'll see that I get cosine of -1, and I just write in or type in 48 divided by 51, and it would give me my answer. So I'm going to go through my last problem on my last column over here, column 4. I have 68. I pick. I'm going to label my opposite, my hypotenuse, and my adjacent. This time I cross out my adjacent. The O and the H is so. So sine of 68, because that's the angle I picked, equals x over 20. Once again, I am going to look at this fraction right here, and I can see that x is on the top. Since x is on the top, I multiply. So x equals 20 times sine of 68. Last triangle on the page. I'm going to pick 33. I'm going to label my opposite, my hypotenuse, and my adjacent. Crossing out my hypotenuse, I'm left with TOA. So tangent of 33 equals 13 over x. I am going to look at that fraction. I can see that x is in the bottom, the denominator. When x is in the denominator, I need to divide. So I'm going to say x is equal to 13 divided by tangent of 33. So right here is every last thing we could do for a right triangle. All the angles either equal 180, I'm going to use the Pythagorean theorem, or I'm going to use SOHCAHTOA if I have a mixture of sides and angles. Last thing, how do I know if a triangle exists? Well, I'm going to have to take the two smallest sides add them, and then see if they're bigger than the third side. So let's look at a few of these. Step 1, 6, 3, and 8. What is my largest side? 8. So I'm going to take 6 and 3 and add them together. I get 9. Is 9 bigger than 8? Yes. So yes, there's a triangle formed. Let's look at another one. 2, 1, and 3. 3 is my biggest. Most of the time my biggest could end up there, it might not. I get 2 plus 1 is 3. Is 3 bigger than 3? No. So this is not a triangle. It has to be bigger. It cannot be equal. So let me look at one more. 8, 6, and 1. 8 is my biggest, so I take 6 and 1 and I add them together. I get 7. Is 7 bigger than 8? Nope. Also, no triangle. Now, how do I know if there's a right triangle? That relationship has to be true. I can plug in some numbers in my calculator and figure out if c squared is the same as a squared plus b squared. Make sure that c is your hypotenuse and it's the largest number. So if I look at one from above, if I look at 6, 3, and 8, I'm going to say 8 squared is equal to 6 squared plus 3 squared. It was the only one that was a triangle, so I can't prove that it's a right triangle if it's not a triangle. 64 equals 36 plus 9. 45 is equal to 64. Nope, nope, nope. Not a right triangle. It has to have that measure. So, with that, we have now completed reporting category 2. One more time, this is everything you need to know about right triangles. Just read through the list, make sure you understand it. If you have any questions, talk to a teacher.